Okay, so what we're going to look at next is sets. Now, sets are very important within Swift because if you're dealing with anything like core data or other things and you do queries via core data, the results get returned as sets. Also, sets give us the ability to get rid of duplicates. So if we've got a dictionary or something else and we put it into a set, we can get rid of duplicates. So we'll have a look at these. So first of all, we'll look at constant sets, and then we'll look at sets that are variable sets. Okay.
Cool.
So sets store a group of values. Sets can be compared against each other. So we can actually put some stuff in there. We can check that they're the same, okay, or different. So first of all, we can specify the type and value of a set by initializing a set. Now you'll notice it looks a bit strange because we have to use set and then these square brackets, but we're passing it an array effectively. So the syntax is a bit strange compared to, say, dictionaries and also arrays, but you tend to initialize them by passing an array of values in. Or we can also, on the second example, we can pass in a range. So here we've got a range of 1 to 10, but notice they're all ints here. Now we can also have the third example, an example where we get rid of duplicates. So here we've got an array with duplicates in it, and we create a set. And what happens, because you can't have duplicates, you can only have one of each type, it strips out the duplicates, which is quite nice if you just want to find out what your core values are in there rather than all the duplicates you may have. Okay, so that's quite a nice feature of the set. Now, if we want to get a value from a set, we don't have a subscript, so we can't just go and grab something from it. We actually have to write a set. Yeah. So here we've got a set of doubles, and what we then do is we have to do a for loop through it to find out the values. Okay. So that's something slightly different there if we want to print it. Now, the other thing with sets that we can't do is we can't make an any type set. And the reason being, any isn't hashable. Okay. So because any isn't hashable, we can't do that. So this line, let things set of type any, is not allowed.
Yeah, that makes sense.
Okay. Now we can store a set within a set. So here we have a set of 1 to 10, and here we have a set of 11 to 20. And what happens is we have a new set where we're taking the first set and the second set and storing it within there. So we have a set within sets. Okay, so you can do that.
Could you combine that set into one?
You could. I think. Do you remember that? What was it yesterday? That thing. I can't remember that command. That probably works on sets where it flattened the array.
Yeah, okay.
It will probably do the same thing. Now you can also count the number of items in a set using set size myset.count. You can also check to see if it's empty as well, just like you can on any collection. These we've seen across all collections that we've looked at. Now, we can also do drop first and drop last, like we could on dictionaries and arrays. The only trouble is every time we run it, it could be in a different order because sets aren't stored in any particular order. So it's not just, you can do it, but it's not really useful, if you get what I mean. So, but it's consistent with other collections. Now, also, you can get the first member of a set by using the function first, but again, it can be different every time you run it because it may store it in whatever order it finds best in memory. Now, then we have variable sets. So variable sets allow us to do a few other things. So with variable sets, what we can do, we've got a set name here where we've got a set of strings and we've got the Dr. Dalit Khan, the master. We can now insert into that set Davros. So just like we could with arrays and with dictionaries, we can insert things. We can also remove things. So if we tell it exactly what the thing is, we can actually remove it from the set. And also we can remove all and keep capacity as we could with other collections. There used to be a lot more things in sets, but they've removed an awful lot of methods over the years. So initially when sets came out, there were loads and loads of methods, but now they've just given you a limited subset which you can build all the other functionality from.
Okay.
So one of the first ones is combine, which is basically a union. So if you remember set theory years ago as a kid, where we learned about sets, you've got your Venn diagram, and union is where you take two sets and combine them. So what this does, you can create this. So we have let combine set equal range set dot union, and we give it the set and the other set, and it will combine both of them. So range set and range set 2 get combined into one set. Okay, and the new set is of the same type as the two sets. The two sets must be the same type. They can't be different. Okay. Now we can also find common values using intersection, which is where we find what is common between the two sets. So if we have range set 2, which is 11 to 20, and range set 3, which is 15 to 30, then we can have the intersection set, which is range set 2 intersection with range set 3. And this will give you any values that are common between them, which in this case will be 15 to 20.
Yeah.
Okay, so that's fairly straightforward. We're going to do a lab on this. As I mentioned, there used to be other methods that we could use, but you can actually build them from those two common features. And I think they just, to make the language less cumbersome, they remove them so that if people, because sets are only used in very defined cases, if people want to do them, they can use a combination of those two things to work out all the other functions. Okay.
Yeah. Okay. Okay. Yeah.
No problem.
Awesome. Let's do the lab.